I have put closures and the whole discussion about stack and heap and so on consciously into today's lesson, because today's lesson is primarily about the C# type system. The C# type system. And again, I forgot about the great new feature that I can select the .NET 5 console app at the beginning. You are perfectly right, so I have to fix that one. Good.
How do I use this new feature?
Somebody just said it's possible now.
Yeah.
How? File, new.
I just created a new project, and there is the project name, then you press next, and then target framework, and there's .NET 5.
Really?
Yeah.
At least not on my machine.
I don't know.
It works for web applications, but I have never seen it for console apps. Maybe you have something new? We don't care. It's so simple to change .NET 5 here. It's not a problem. Good. Let's do a short quiz. Let's see. What are the basic data types that C# knows out of the box? I'm not talking about custom classes. Let's just shout out data types that come to your mind. Come on. Yeah. Int, correct. String, correct. Double, bool, right. Float, short. Long, Character.
Word.
Huh? Word. It's really a basic data type? Not sure. Anything else? Let's take a look. I am looking for a specific doc page. Give me a second. Built-in types. That is good. This is what I was looking for. What do we have? Bool, byte. What is an S byte? Correct. Char, decimal, double, float, int, uint, long, ulong. What is ulong or uint? Yeah, correct. Short, ushort. String, object. We will have to talk about that. Dynamic. We will have to talk about that. Nice. Let me quickly take a look. Anything? Is anything not that well known for you? What do you think compared to other programming languages? Like, for instance, JavaScript. Which data types are very specific to C#? Which are not absolutely present in every programming language, yes? Short, something similar exists in most programming languages. The what?
The data types with the U at the beginning.
No, they are nearly in every program, not in JavaScript, but there is one data type which is very, very specific. I will tell you. Really, exactly. What is decimal?
I think it's just a very big one.
Just like float, double. Why do we have decimal when we have float and double? So let's ask the question differently. When do you select a float or a double, and when do you select a decimal?
The difference between double and decimal is double is Gleichkommazahl. And decimal.
A floating number.
And decimal, you have a fixed number of digits for the digits before the comma and after the comma.
Okay, I like that. So if you want to store, for instance, a monetary value, an account, a balance of an account, Kontostand, for instance, in money, would you choose float, double, or decimal? Decimal, exactly, because decimal will never lose data. If you store the value, let's say 1, in this value, in this decimal, it will always be 1.0000 and a lot of other zeros. It will never happen that you store the value 1 in a decimal, and when you ask it for its value, it will return 0.9999999, as many nines as there are possible to be. That will never happen. Can that happen with float or double for some specific numbers? Definitely it can. If you use JavaScript, for instance, and you write a certain value into a numeric field, for instance, value 3 or whatever, it can happen if you print it on the console that you get 2.99999999999. Is that a good idea for a balance of an account? Probably not. If you would like to store the distance from Earth to the Sun, for instance, in, let's say, kilometers, then it doesn't matter whether you have a small difference. It's just important that you can store very large numbers. Understand what I mean? That's a big difference between float, double, and decimal. So in our world, where we build business software, we very frequently use decimal. So if I ask you, for instance, in an exam, to build a solution for any kind of banking system, or whenever you have to deal in a database with monetary values, with money, please don't use float and double. That is a very, very bad idea. Use decimal. Got that? Okay, basic data types. That's simple. These types, here you see the C# keyword, here you see the .NET type. Is it the difference? You don't need to follow along that. Is it the difference whether I write int x equals 42 or int 32 y equals 42? Is there functionally any difference? No. Is there, from a performance standpoint, any difference? No. Because this small written int is just a synonym for the big int 32. Question?
Actually an object has just been encapsulated.
That is not correct. That is not correct what you just said. You said an integer is an object that is somehow encapsulated. No. Here we have a huge difference between C# and programming language and other programming languages. I'm getting in the area where I don't know a lot about Java, but maybe Java works like that. Maybe old Java has worked. Okay, then in Java it's also not the case. Thank you for pointing that out. An integer is an integer, point. It's 32 bits, that's it. No object around, no object orientation here, it's just an int. Full stop, that's it. Okay? And as I told you, it's exactly the same. It doesn't matter whether you write this or whether you write this. But it is good practice to use the smaller cased versions. So use small int, use small string. Don't use uppercase string. It works, it's the same, but it's not considered as, let's say, easily or good written C#. But sometimes, yeah, it is necessary. Good, good, good. I agree. Strings. Let's quickly talk about strings. This is a string, right? C# strings. Let's quickly recap that. Just ASCII or Unicode. Could I add an emoji here? Would it work? Could I add an emoji here? Definitely I can. That's fine. Could I use Chinese letters in a string? So, is it ASCII or Unicode? Unicode. How many bytes per character? Leaving out very specific languages which are super complicated, but in general. Huh? 1 byte or 2 bytes? 2 bytes, exactly. Exactly. A string in C# is Unicode. Okay? It's not a single byte. That's a big difference to languages like Go, for instance. Go uses UTF-8 internally. Okay, good. Can we manipulate the type, a string? Can I exchange, I don't know, the n with an x? No. That's super important. Remember that. Strings in C# are immutable. Once created, they cannot be manipulated anymore. It's simply not possible. If you manipulate anything, you always create a new string. And I think this is what you meant, what you had in your mind. You can manipulate whatever you want, but essentially, listen, that's important, you're creating a copy. One of you, I don't know who, created a short talk in our Flipgrid exercise about string builder. Who did that? I enjoyed the video, thank you very much. And in your video you showed that string builder is much faster than strings when you concatenate them. Why? Because when you manipulate the string with a plus, concatenating it or whatever, you're always creating copies, and creating a copy takes a while. Understand what I mean? So if I do something like this, my name dot to uppercase. And now at the end I write console write line my name. What will be the output of this program? Yeah? Exactly. Why? Correct. To upper takes the string and returns a new string. You see it here? Returns a copy of this string converted to uppercase. So if I run this guy, we have the original value. If I say something like this and run it again, I now get the uppercase value. So remember it, strings are immutable, unchangeable. Somebody in the video, in his video, Flipgrid video, was talking about unmodifiable things. The correct technical term is immutable. To mutate means to change, okay? They're immutable. Good. So we covered strings and basic data types. Next will be object, dynamic, structs, and classes. But before, I think we have a break. Is that correct? Exactly. So let me see. Good. We now have the big break, so we'll see each other at 10 sharp, okay? Good. Welcome back. Third lesson of today's class. Any questions to the topics that we did in the previous hour? No? Okay, good. We stopped discussing the type system. Sorry, here is the type system. And the type system next has this strange thing which is called object. This is really specific to C#. This is not something that you can find in JavaScript, for instance, at least not in the same way. You cannot find that in Rust. You cannot find that in Go. It's very specific to C# compared to other programming languages. So my question to you is, what is object? Uh-huh.
Sort of the base object where every object inherits from that object.
Okay. Does int inherit from object? That's a hard one, isn't it? Yeah.
Int isn't a class, int is a struct.
No.
Int 32. Methods are declared in a struct.
It seems like. But what you said int is a struct. No, the built-in data type that you see here, they are deeper.
That's why I corrected myself.
Correct. The methods seem to be implemented in a struct. You're right. In reality, the C# compiler is much more intelligently handling the base data types. But yeah, you can think of mental model. Int is a kind of implemented its behavior in structs. What I mean is, if I add two numbers, 1 plus 2, the C# compiler will never call an add function implemented in a struct called int32. It will generate a processor instruction for adding two numbers. Understand what I mean? So this is what I meant. With the built-in data types, they are something very specific. So now int is kind of struct, kind of special, and you said object, everything is derived from object. How does that go together? Because if we take a look, object here is a class. Int is a built-in data type. You said a struct. How can int be derived from object if it isn't a class? Understand the problem? That's a really fundamental problem. And if you want to understand how C# works, you have to try to understand exactly that problem. What do you think? How do they solve that? Imagine I do the following. Does it compile? Yes, it does, as you can see here. Object O is a struct or a class? A class. Does a class live on the stack or on the heap? Heap, correct. What is 42? Integer. Does the integer live on the stack or on the heap? Well, in this case, it doesn't live anywhere. It's just a number. It's just a literal and a constante. How does that go together? Where is the constante, the literal 42 stored? Stack, heap, nowhere? What's going on here? Does anybody have an idea? You say heap. Okay, let's stick with that. It has to be something on the heap. That's correct what you said. What's going on here, and you can remember that, and that is what I want you to remember because it's super specific for C#. It's called boxing. Who has heard the word boxing before? Never? I mean, with the context of C#. Yeah, you heard it?
I've heard of it, but
Uh-huh.
I can't really remember.
It does what it says. It takes the value 42, puts it in a nice little box, and puts it on the heap. This O here is pointing, because it's a class, it's pointing on the heap, and it points to a box, and inside of this box is 42. That's boxing. What the C# compiler does is a nice little trick. If you take a value, a built-in data type, a struct, whatever, what typically lives on the stack, and you assign it to object, it's magically, Harry Potter, fairy dust, magically turned into an object by putting it in a box. And the box is an object, but inside of the box is the value type. Understand what I mean? Question. Why does this program not print out same? In both cases, I have the number 42.
Because the object class implements equals function, which looks at the hash code and so looks
Nope. That's exactly what it does not do. It does not look at any hash code.
I just want to say that it would work if you copy the old O, then it would work, but it's not a copy, so it's not the same object.
Okay, yeah, you're on the right track, but not perfect, yeah? The references are compared. We are comparing the boxes. Understand what I mean? Let's order 2 books from Amazon. They will put it in 2 different boxes. You order the same book twice. Then you get 2 boxes. And then you ask somebody, Are these two things the same? No, they are two different boxes. C# will not look into the box and say, what is inside the box? If you convert it to an object, you're comparing the boxes and not the content of the boxes. The references are compared. Understand what I mean? That's important. That's often the problem what you see here. Why can't I write this code?
Because 42 is the integer and O is the object.
Is an object, so we are trying to compare a box with 42. Not the same types. What would be the correct syntax if I have something like this and if I want to compare the content of the box with 42? Yeah, you were the first?
I don't know if it's existing in C#, but in Java you have a method like string value of. I don't know if there is something like that for integers in C#.
I could cast the object. Somebody did a talk, a short video about typecasting. There it is described. It's something similar, but there is something easier. I think, yeah? Exactly, correct. Object, if we take a look at the object class, and we take a look, object in C# contains a method which is called equals, and if we call the equals method, then everything should work. Let's give it a try. Yes, same, works. Correct, thank you very much. So the method equals looks into the box. Now we are comparing the content of the box with 42, and they are the same. Got it? By the way, your answer was perfectly correct up until the latest version of C#. Because now you can write, and that works with boxes and without boxes. Yeah? And you can also write something like, nice, isn't it? Much easier than writing exclamation mark O dot equals, oh my God. This is much easier to read. But you are right. At the end, the is operator will call equals in the end. Yeah. Boxing. Do we have unboxing too? Of course we have. What we can do is we can say var n equals int o. By casting the object to an integer, what will C# do? It will take the box, unbox the value, and copy the value. That's unboxing. Two very, very important concepts in C#. And that's specific. In this year's curriculum, Lehrplan, we have an important thing that I have to teach you differences between different programming languages. And what you see here is characteristic for C#. That's not something that can be applied nearly equally to a lot of programming languages. This is C#. The closure stuff that we had before, that's generically applicable. Nearly every programming languages that I know has some kind of closure support. Good. That's an object. So everything is compatible with object. What are the functions that object support? So which functions does every type in C# have? Equals. What else? Yep. ToString, correct. It's simple. Turning something into a string representation. What else? Get hash code. What is a hash code?
Hash code is the value put through a hash method and then the hash value comes out.
What is a hash method?
You can get a hash from a value, but you cannot reverse the process.
You cannot reverse the process. Exactly. I recently heard the description and I found it really funny. Somebody said, it's really simple to turn a chicken into a chicken McNugget, but it's really difficult to turn chicken McNuggets back into a chicken. And that's exactly the same with hash codes. Yeah? It's really simple to turn an object into a hash code, but it is not possible to turn a hash code into the object again, because the hash code is a little bit unique, but it's much shorter. Yeah, that's a hash code. Get hash code. Yeah, question?
No, another function.
Yeah, another function?
Get type.
Get type, okay. I think it was your, yeah, exactly. You did the Flipgrid video about reflection, and get type is the jump into the world of reflection. If you want to know what reflection is, watch the video. It is available now on Flipgrid. Good, I like that. Last one, if I go back here, is dynamic. What's dynamic? If I tell you there are statically typed languages and dynamically typed languages, do you know what I mean with that? Is JavaScript a statically typed language or a dynamically typed language?
I think JavaScript is dynamically typed.
Why?
The type of a variable can change.
Exactly, that's the point. Python, statically changed or statically typed or dynamically typed? 50-50 guess probability, dynamically typed. C++, static. Java, static, exactly. And now comes the difficult one, C#. Exactly, that's what I wanted to hear from you. That's exactly the point. C# is both statically typed, int my number equals to 42. If I want to say my number equals to foobar, it doesn't work because it's statically typed. My number has a data type int, and it cannot change. This leads to an error. But if I say dynamic, my dynamic equals to 42, and I say my dynamic equals to foobar, it just works. Understand what I mean? The big problem is that I don't get very good support from the IDE. If I see my number and I use the dot here, I will get all the methods which are specific for the data type integer. But if I go here and say my dynamic dot, I don't get any suggestions. Why? Because C# has no idea what the data type will be at that point in time. Understand it? Why do you think the C# developers, Mr. Anders Hallsberg, added dynamic to C#? Wouldn't it have been better to just stick with static typing?
Maybe if you want to incorporate JavaScript code.
Exactly. If you, it all started way earlier, when JavaScript wasn't that popular. There was a trend in C# where people mixed languages, especially like Python. Python has the best support for that, where you mix Python with C#. Nowadays, you mix JavaScript with C#. And if you want to somehow bridge the gap between JavaScript and Python, for instance, you need something like dynamic. There is a second reason, but you are probably way too young to understand what I mean here. Have you ever heard the term COM and OLE, object linking and embedding? When I was at your age, this was the hottest stuff that you could imagine. When I was in this school, in my final years, the first time it was possible to embed an Excel spreadsheet directly into a Word document. That was huge. Embedding an Excel sheet into a different application was called object linking and embedding. It's 25 years in the past, and the technology used was called COM and OLE. And COM and OLE were also dynamically typed. This is why C# was there. Nowadays, yeah, Windows is based on it, but it doesn't, yeah, you don't really need it anymore. So dynamic is the bridge between a statically typed language like C# to a dynamically typed language. Question: which library would you use to embed JavaScript code into C# code? Or the other way around, to embed a C# code into JavaScript and run it from within your JavaScript code? Any idea? No? There is a nice library. It works pretty well. It's called Edge.js. Yeah, it works pretty nice. If I scroll down, see, this is, you can see, this is JavaScript, here, JavaScript. And here, just within this nice little JavaScript stuff, you have C#. And what you get back is a JavaScript delegate, and you can simply call it, and suddenly you call C# from JavaScript. And of course, it works in the other way too. Here, you have C#. This is a little bit of JavaScript. What you get back is a delegate to a JavaScript function, and you can simply call it. Understand what I mean? And this is why dynamic exists. Will you use dynamic in this course? Probably not. You only use dynamic if you have to bridge the gap between a statically typed and a dynamically typed language. So it's important to understand it, it's useful to know, but for many cases it's useless detail knowledge that you can just forget about, because yeah, you will rarely use it. Questions? Clear? Good? Nice. Nice, nice. So, if we go back to the documentation here, now we have worked through the built-in types, I like that, and we have worked through the object, string, and dynamic types. They are a little bit special. Good. Next one, we have to talk about an important thing here, struct or class. Somebody did a Flipgrid video on whether to use structs or classes. There was a small mistake in the video, and I corrected it in my feedback. I don't know if you have listened to my feedback already. Okay, so you are not allowed to answer now because you did this video. Yeah. What is the difference between structs and classes in C#?
Und Celia hat immer gesagt, Structs sind Klasse für Arme.
Klassen für Arme. Okay. The poor man's classes. I do not fully agree with it. You're sitting in front of your computer, you're writing code, and you have to decide, I create something, let's call it person, which has a first name, a last name, an address, a zip code, a street, a town, a reference to a country. Should that be a class or a struct?
Depends if you need methods.
No, that's wrong. That's a misunderstanding, it seems. Structs can have methods, absolutely no problem, just like classes. No difference. Yeah, small differences. But in general, absolutely no problem. Add methods, it perfectly works. Don't believe me? Well, datetime is a struct. Take a look at the number of methods that datetime support. Of course, it is possible. Absolutely. So, struct or class. You were next.
I think if it is possible for you should use a class if two objects should not be the same, even if all attributes are the same.
Yes, you are right, but it's very abstract. If you think of a student in a lower class and you would describe it like that, they would have no idea what you are meaning. We can simplify your description. But you're right.
And the big difference is that there is no inheritance with structs.
That's not true.
No?
Structs can derive from each other. Structs can implement the interfaces. No, they can't do that. Absolutely. We had that before. Before we had value types and reference types. Is a struct a value type or a reference type? Yes.
I think a struct is a value type.
Correct. Is a class a value type or a reference type? It's a reference type. What does value type mean? Now, take a look at following. I create a function, void do something. Var dt equals new date time. dt, date time is a struct, correct? Does this date value live on the stack or on the heap? Stack. Why? Because it's a struct and it's a value type. Correct. It lives on the stack. Woohoo! That's exactly what I wanted to hear. So if I say var dt2 equals dt, what happens in this line? Does dt2 live on the stack or on the heap? On the stack, because it's still a date time. If I would modify dt, it's not possible because it's immutable, but if I would modify dt, would I also modify dt2? No, why? Because for value types, if you assign them, what happens? They are cloned, copied, exactly. Here, in this line of code, they are copied. You create an entire copy of your struct. That's what's happening here. Whenever you take your struct and give it to somebody else, you are creating a copy. So what do you think? If you have a huge thing with a lot of properties, would it be a good idea to implement it as a struct? No. Why? Yeah?
Because then you would copy it.
Yeah, you will copy it. If you pass it to a function, create a copy. If you return it, create a copy. If you assign it, create a copy. You always create copies. Your CPU will be busy creating copies over copies over copies over copies. If we create a class, for instance, what can we create? The string builder. There is a Flipgrid video about string builder. You see? Class. Where does the string builder live and store its data? Well, it's not difficult, right? For value types, we said they live on the stack. This is a class, this is a reference type, so it lives on the heap. Exactly. And if I say var sb2 equals sb, do we create a copy of the string builder? No, but we have two references to the same string builder. Understand what I mean? So, one of the most important things when it comes to structs and classes is if the thing that you are building is small, a few bytes, a few dozen bytes, create a struct, or at least consider a struct. If the thing that you create becomes pretty large, has a lot of properties, a lot of data, maybe hundreds of bytes, kilobytes, megabytes, create a class. It should live on the heap. This is what the heap is for. Understand what I mean? If something is small, a struct might be a good thing. If something is huge, a class is a good thing. Yeah?
But is it okay to just use a class?
No.
No?
No. Well, your question was, is it okay to just use classes? My answer was for professional programming in the real world outside. Is it okay for this course to always use classes? Yes. It's okay. I don't assume that you will perfectly be able to decide whether to use a struct or a class. You can try it when you think it makes sense and you want to get experience with it, try it, that's fine. But for this class, if you are not sure, always take a class. So your teacher who said structs is a poor man's class, and probably he wanted to tell you use classes and don't think so much about structs. He was right for this school, and he was right for you learning to code. If you live in the outside world and you're a professional C# programmer, you will every now and then create structs. Definitely.
I have a rather strange question. If I make a class library in my
Yes.
solution,
Yes.
can I add a struct to it?
Yes. Absolutely. Structs are not that different. A struct and a class from C# point of view, from type, yes, there are some differences, but they are minor. The most important difference is that one lives on the stack and one lives on the heap. Yeah? There are even some very specific features, very nice features, that structs can do and classes can't. When it comes to parallel programming, when you do a lot of multi-threaded programming, you will create more structs than classes. Let's compare it to other programming languages again. Go, for instance. Do they have the concept of structs and classes? Do they have classes at all? What do you think? No, no. Go doesn't have classes. Go doesn't have classes. Does Go have structs? Oh yes, structs are there. So Go only has structs. What do you think? A Go struct, does it live on the stack or on the heap? Heap? You know what the answer is? Don't care. A programming language like Go has been explicitly designed so that they say, don't care about it. Just create structs and don't care about whether we put it on the heap or on the stack. That's up to the compiler. The compiler looks on your code and says, in this case, I will put the value on the stack. And in another case, it might put the value on the heap. You don't care. Don't be smart. That's the idea of Go. What do you think about Rust, a very modern programming language? Yeah.
Rust has structs, but no classes.
Yeah, exactly. Again. What about JavaScript? Does JavaScript has structs? No. Does JavaScript have classes? Yes, exactly. So it's different in JavaScript. In JavaScript, you don't have control over stack and heap and all this stuff. They just call it a class. So you see, the concept of having structs living on the stack, being a value type, and classes being a reference type, living on the heap, is something which is specific to C#. Other programming languages, different approaches. Imagine the following situation. I give you a homework, and in this homework you have to design a data type which represents a point in a three-dimensional coordinate system. Maybe you are building a game engine, and you need to represent a point in 3D, x, y, and z axis. Struct or class? Struct, I agree. Correct. It represents a single logical value. I think you said it in your video, and that was perfectly correct. A single logical value, a point in a 3D coordinate system, struct is a good idea. I'm currently working on an exercise for our programming club, which implements the classical battleship Schiffsversenken game. A coordinate on this battleship board, A1, A1 for instance, struct or class? Struct, correct. Exactly, exactly. A data type which manages the whole board for the battleship game, storing all the ships where they are positioned. Struct or class? Exactly. Why? Because it's much larger. We have at least 100 bytes. If we only save a single byte per field, then we have at least 100 bytes. And 100 bytes would be pretty large for a struct. I would not use a struct for that. What do you think? Microsoft, if you take a look at the base class library, are there cases where Microsoft gives you both options? They give you a class and a struct doing nearly the same thing so that you can decide whether you want to use it on the stack or the heap. Do you think something like that exists? Absolutely. There is a class task and a struct value task. There is a class tuple and there is a struct value tuple. That exists. Because in some cases you do this and in some cases you do that. So what I want you to remember is that structs and classes both have their pros and cons. It is not clear to always use classes. Structs have their area where they are unbeaten. But for this course, for your homeworks, for your exams, I'm perfectly fine if you always use classes. Because designing structs and implementing structs correctly, I would love to show that to you, but it takes much too much time. Implementing structs correctly is not trivial. Really not trivial. So therefore, classes are fine. Good. Questions regarding structs and classes? Want to see a struct? A correct struct? I can show you one which I have written recently. This is the example. Maybe we'll use this example in this course too at one point in time. And there, for instance, I've implemented a struct which is called board index. It's representing an index in Schiffvoll versenken battleship board. And here you see this is a struct. It's read-only. What do you think that read-only means here? Yeah?
Cannot be changed.
Exactly. It's, what is the correct technical term? Immutable. Exactly. It tells C# that this is an immutable struct. I implement I equatable. That means that I can compare two board indexes. I store the value of the board index in a read-only int. Yeah, and here you see a static method, a constructor. Structs can have constructors. Another constructor. Structs can have constructor overloading. Let's go down a little bit. Here, static method, static. Here, you have a non-static method. It's absolutely okay to have them. Here, non-static method. Here you see inheritance, virtual methods, overriding, definitely possible. So you see, a struct is way more than just a trivial thing holding two values or something like this. It can be something that is really complex. Got it? Understood? Yeah?
Wenn
Question?
die Struct dort via read-only,
Yes?
du hast nur ein Field machst du read-only, so ist das Field automatisch read-only, wenn der Struct read-only ist?
The question is, could I leave out this read-only just because of this read-only? I'm not sure with the field. I am definitely sure that it makes sense to write read-only to the methods of a read-only struct. Because C# does something very strange. If you create a function on a read-only struct, which is not read-only, you are allowed to do that. But what it internally does, before it calls the function, changing the values of this struct, it creates a copy and calls the function on the copy of the struct so that the original value remains unchanged. It's a little bit strange. You don't need to remember that. That's a very nifty detail. I know the behavior here. I don't know explicitly whether we could leave that out or whether the C# compiler would complain. I would have to check that. But I'm definitely sure that this works. So maybe it's double information, but yeah, good question. You can try it if you want. I don't know the answer to that. Good? Clear? Structs, classes, thumbs up, understand it? Good. Then we have, what is the time? Yes, we are good, we are good. We have a little bit more than 10 minutes, that's perfectly fine. My question to you is, I told you, yeah, we had unboxing, we had boxing, we have statically typed and dynamically typed structs or classes. Now, my question is, we talked about if we have a struct here, that it lives on the stack. Just to remember, when will C# clean up? When will it remove dt from memory? When it lives on the stack? Question? Answer? Where?
After the functional method has finished.
Correct. Good. When will C# remove the string builder from memory?
When the reference to that specific object doesn't exist anymore.
No. No. Your idea is correct. Somebody created a string builder, which is a class, yeah? Or a person class, or your order class, or your database connection class, whatever class you have. If you create such a class, it lives on the heap, correct? Now you have a pointer to that heap. You have a connection. We talked about it here. Here we have two references. It would look, if I draw it, it would look like that. Here we have the string builder. Sorry, with the mouse I cannot draw very well, but I think you will get the point. And here is our first reference to this one, and then we have the second reference to this one. And what you said is, once both references get out of scope, so once both references are deleted, the string builder is also gotten rid of. And that's wrong. That's wrong. When will the string builder be removed from memory? Yes?
When the program is finished?
No. If that would be true, and we would create lots and lots and lots and lots and lots and lots of string builders, we would run out of memory. What do you think? C# has something which is called a Reinigungsfachkraft, a garbage collector. Yeah? Do you know what a garbage collector is? What does the garbage collector do? You want to try and answer? Yeah.
It gets deleted when it's not used anymore.
It gets deleted when it's not used anymore. No. Yeah?
It's delete something if you don't, if there isn't a pointer.
No. If I take that this handkerchief and I throw it on the floor, I don't use it anymore. Will it be cleaned up? Will the Reinigungsfachkraft, I don't know the English term, the cleaning person come immediately and remove it because I don't use it anymore? No. When will the cleaning person come and clean up my mess? Somewhere in the afternoon, right? Or in the evening, correct? Imagine that I have thousands of these packages here and I throw them on the floor and we cannot even walk inside here anymore. What would we do? We would call the cleaning personnel and tell them, hey, we have made so much garbage. Please come and clean up. So when do you think the garbage collector will clean up our string builder?
There isn't enough space.
Exactly. It monitors exactly how much memory your application has left. And if the memory becomes critically low, whatever that means, we could talk for hours about how the garbage collector does that. It's very, very smart about that. When we don't have any space anymore, it comes and cleans up our mess. All the things that we don't use anymore, where we don't have any references anymore, it will clean it up. Somebody did a Flipgrid video about finalizers.
Yes.
Yeah. So the finalizer runs when?
Garbage collector.
Exactly, when the garbage collector runs. And it was perfectly right in your video. The second thing is, if the computer is currently idle, nothing is happening, the garbage collector might also decide, it's a good idea, nobody is using the computer, there is enough calculation time, so let's clean up, just to be sure. Do you know exactly when the garbage collector will kick in C#? No, you don't. The garbage collector will kick in whenever you have created too much garbage.
Can you force the garbage collector?
Yes, you can say, and you had it in your video if I can remember it correctly, GC collect. This will run the garbage collector. GC stands for garbage collector. This will tell the cleaning personnel to now come and clean up. Yeah.
I'm pretty sure we learned just last year you can save the reference to an object on the heap. Does this count as that there's a reference on this object even though it's not used anymore in variable?
Yeah, absolutely. That's no problem. You can be sure that the garbage collector is really, really smart. So you have a reference to a reference to a reference to a reference to a reference referencing something on the heap. That's possible. Imagine that you have a list of students, and every student has a reference to an address object, and the address object has a reference to a country object. Then you have a reference to a reference to a reference to a country object. The garbage collector will recognize that. And that is the reason why garbage collecting is really a lot of work. The garbage collector eats up your CPU. Now listen closely because that is important. As a very good C# developer, you care about the mess you make. You care about the number of bytes you allocate, because the more often you allocate memory, the more the garbage collector has to do to clean up behind you. I have seen professional programs. I was hired as a consultant to go to companies in Germany and help them optimize their code. And guess what? We found out that 15 to 20% in this specific process of the CPU time was dedicated to garbage collection. They didn't write poor algorithms. They just created too much garbage. We had to rethink their strategy of allocating memory. Understand what I mean? And once we rethought that, the garbage collector effort drops down and is pretty good. It can pretty good be, the software became much better and it was faster. Garbage collecting, important thing. Questions? Remember that? So the garbage collector is relevant for what? Value types or reference types? Reference types, correct. And it will kick in when? When there isn't enough space, or when there is just time. What do you think? Does C# have one strategy for garbage collection or multiple strategies for garbage collection? What do you think? Multiple. Okay. For what, for instance? Why should they have multiple? The reason is there is a huge difference between a client application running on your desktop computer and a server application. So for instance, the garbage collector behaves differently depending on whether you run your software on a client computer, think of WPF, WinForms and so on, or on a server, which runs a web API, for instance. We will not talk about the details about that in this course because we simply don't have the time. How could you measure the amount of time that your garbage collector took? What do you think? Is there a tool for that? Yeah. Yes, there is an awesome tool. We'll not use it in this course, but I would like to tell you about it. It's called PerfView. It's open source. It lives on GitHub. If you take a look, 2,300 stars, very, very up to date. And if you ever have a problem with garbage collecting overhead, fire up PerfView. It is, believe me, the most ugly user interface that you have ever seen. Really, this is crazy how ugly this stuff is. Let me show you a screenshot. PerfView screenshot. Yeah. This is a video. Yeah, it looks something like this. I don't know if you can see it here. It's really, really ugly. It's gray and it's full of data and data and data, but it is going very, very deep. This tool is used by Microsoft internally to optimize the Windows kernel. So it's really going deep. You don't need all the details of PerfView. If you just want to track the garbage collector time, this is really simple with PerfView. You just say, do a garbage collector analysis, and at the end you get a nice little HTML file. And in this HTML file it tells you, I don't know, 17% of CPU time was spent garbage collecting. Then you know you have a problem. Okay? So PerfView would be the correct tool for that. Good. And with that, I think we are done for the theory lesson today. I encourage you to take a look at your colleagues' Flipgrid videos. For every Flipgrid video, I will record a short response where I give some tips. Maybe there was a missing information, or maybe there was a mistake, a technical mistake, and I will correct it. It only takes you partly 1 minute or 2 minutes per topic, but you can recall some of the important C# functionalities. So take a look at the Flipgrid videos. Thank you for all of you who have already handed in the videos. I got asked, for me, it's fine if you hand in the video today. If you haven't done it yet, tomorrow or on the weekend, I will take a look at the remaining videos, and then I will also note down who not did the video, okay? So if you want to handing it in today, that's perfectly fine. You had a question? No? Good. Good. For that, thank you very much. We have 5 minutes break, and afterwards we will do exercises. Then you can code.